Exercise set A, question 4. For this question, it is important that you know the definition of a weakly stationary series. And of course, you need to know what is autocovariance and autocorrelation. If you know these two definitions, it's going to be very easy to do this question. Now going to part A. In part A, we are asked to calculate the expected value and variance of x of t. So going to the solution manual. Here, according to the definition of a stationary process, we have the following. So remember, when we say a process is stationary, it implies that the expected value of all time is constant. So here we call it mu. And the variance also is constant. So here we call it some sigma squared of x. Therefore, taking expectation from both sides, we simply write the formula and take expectation since it's constant. And if we expand it, there will be the expected value of xt minus 1, which is going to be mu, again constant, based on this definition. We use this definition here. Solving for mu, we obtain that mu is equal 1. Similarly, for variance, we again use the definition and this property that for a stationary process, the variance is going to be constant. So we simply take variance from both sides of this the equation of this process. After expanding it and remembering that variance of xt is equal to variance of xt minus 1, and all of them will be equal to this sigma x squared, and replacing it, and again remembering that we need to plug in the equal value of the variance of epsilon here, and solving for sigma x squared, it's going to be 10 sigma squared, and plugging in the value given in the solution statement for sigma squared, finally we obtain that the variance of xt is equal to 1. Now to the next part, part B. It asks us to calculate the covariance between x of t and x of t minus 1. That is two consecutive values. We are interested in knowing their covariance. And note that if we have the covariance, the correlation is just a step away. So let's do this exercise. Let's go to the solution manual. The trick or method to calculate covariance time series problems is that usually this trick works, that we replace one of those variables with the equation and calculate the covariance of those variables based on the given information in the problem statement. Here, if we replace this x of t with the given equation, which is here, we simply find that it's going to be a linear combination of this expression, two random variables, which we can simply calculate the covariance of those expressions. And here we just need to keep in mind that covariance of same values will be the variance of the same random variable. And remember that covariance of epsilon and any x is 0 as given in the question statement. So this is going to be the final result. Going to the next part, we are supposed to calculate the correlation. Well, as I mentioned earlier, when we have the covariance, correlation is going to be one step away. So we already calculate this nominator, covariance of x of t and x of t minus 1. We already also calculated and we know how to calculate the variance of x of t and variance of x t minus 1. So if we plug in all those known value or the values that we already calculated into this, which is simply of the definition of correlation, we will end up with this number, which is the correlation of x of t and x of t minus 1. So this is it for this question.